We're back. We're back for our last video for this lecture, which is about misleading visualizations. So there are three denominator related issues when it comes to visualizations. One is make sure that they include denominators. For example, that population maps issue we talked about earlier. So we're not going to revisit that here. The second is don't plot shifting changes over time. I'll show you what I mean by that. And the third is always check your axes to see how big the changes implied by the graph actually are. So let's focus on not plotting shifting changes over time. If you plot over time changes from just the prior point to the current point, you can create incredibly misleading graphics like this one from Donald Trump here. And in my mind, it's really an issue of using the wrong denominator. Let's look over here, though, at a baseball game, the score in a baseball game, Seattle Mariners versus the Detroit Tigers. From inning 1 to inning 2, there was no change in the run differential. From inning 2 to inning 3, no change. They both scored 1 run, so this stays at 0. From 3 to 4, there was no change. From 4 to 5, from 5 to 6, no change. From 6 to 7, the Mariners went down by 5 runs. In the 8th inning, they went down by another 4 runs. So the situation got worse, but by presenting just what happens from one point prior to the current point, it actually looks like the situation got better for the Mariners, even though they gave up another 4 runs. You see how it's subtle, but it's incredibly misleading. And then the Mariners finally scored another run in the 9th. And so it jumps all the way from -4 in the 8th inning to +1 in the 9th inning, even though they lost the game 10 runs to 2. Donald Trump is doing the same thing over here with this economic recovery graph. Jobs in every month, we're gaining a small number of positive jobs. That's good, that's good, that's good. The pandemic hits. We lose tens of millions of jobs in 1 month. In the next month, see how it's on the uptick here? This actually represents losing another 18 million jobs, even though the graph is going up. We lose another 10 million jobs. And then finally, we get about 7.5 million jobs back. But it looks like we're better off than when we started, even though we're still millions and millions of jobs in the hole. Okay, that we lost millions and millions of jobs. That's how subtle and clever these bad graphs can be. So my advice is always either just plot absolute numbers or plot cumulative changes from a single reference point, like August 2018 for jobs. That would show a huge decrease and then a slow starting to come back, right? But we'd still be below where we started, and that would be a lot less misleading. The last major thing I want to talk about is always checking your axes. So if I showed you a plot of the Dow Jones Industrial Average, the stock market, from 1920 to 1940, you would see quite a bit of little perturbations here. And it would look like it went up a lot and then it went down a lot. But check out the axes. It's only running from 100 to 400. And it looks a lot more volatile over here in this period than it does in this period from 1950 to 2020. But you got to compare your axes. Here you have a much bigger axis. So smaller changes are actually much, much bigger in absolute terms. So it's always important to check your axes and try to figure out how big the changes you're seeing actually are. Because manipulating axes is a really common way for people to try to bullshit you. So some just interesting history. The Dow Jones Industrial Average started with 12 companies. It's now at 30. General Electric is the only one that's been there the whole time. And some fun old-timey company names that are no longer in the Dow include U.S. Leather, Distilling and Cattle Feeding, American Cotton Oil, and American Sugar, some bygone companies. Here's another example from sports. here are three graphs that look roughly the same. If you're just looking at them, you see similar upward trends in all three. But let's take a look at this one in basketball, in the NBA, the percentage of shots that are taken from three-point range. In the NBA, that increased in the last decade or so from about 22% to nearly 40%. That's a pretty big difference in the percentage of shots taken from three-point range. If we look at baseball pitch speeds, fastball velocity, we see about a 1 mile an hour increase from 92 to 93 over the last decade. It looks the same, but it's actually a much smaller, slightly less uh, big deal of a change. And then golf carry distance, I don't know more about how far golf balls are supposed to carry, but it's only increasing about 3% here from 290 to 300 over a decade. Whereas you're nearly doubling in the NBA and you're increasing only about 1% in MLB, but these three graphs look almost the same. You see how you can really mislead people? Check your axes. Make sure you're sending the message you want. Here's just a favorite example of mine of a bad data visualization, and I've got one more coming up too. Heights by country. Latvia, apparently gigantic women. They're all Godzilla at 5'5". And India has nothing but little people at 5 feet, apparently. So maybe a relative measure would have been better here. But actually, I just wouldn't, I would have had my y-axis start at 0 rather than at 5 feet here so that the differences aren't exaggerated. All right, this bad data visualization is just for fun. But Abby's tweet here definitely made me laugh out loud. The chart using grainy JPEGs of national flags as data points isn't real. It can't hurt you. The chart using grainy JPEGs of national flags as data points. It really obscures anything you're trying to see. So don't create graphs that are too crowded. That's just a good piece of advice. Unfortunately, we don't have time to get into it here, but bad and misleading data visualizations are a huge problem. And if you're more interested in learning about how you can both make sure that you don't get taken for a ride by one of these and that you can recognize when somebody is misleading you, and to make sure that you don't accidentally mislead others, I highly recommend Chapter 7 of a book called Calling Bullshit. It's only $22 on Amazon. It just came out this year. It's a phenomenal book. I really, really recommend it. You can also, for free, go to their website and look at some of their discussions of visualizations here. And not all visualizations are bad. I mean, if I'm telling you here are the bad liars, I want to show you some people who are good at it too. So you can go to this Twitter thread from The Economist, or excuse me, from the Financial Times, which I think has some really, really good visualization work. I think 538 and The Economist generally do really strong visualization work as well, as does the New York Times and many other reputable news outlets. So in summary, using denominators, really important. Using the right denominator is arguably even more important. Ask yourself, does the denominator you're using and the statistic you're producing answer the right question? Does it tell the story it should? Match your denominator to your numerator. Ask yourself, did the analyst, either you or somebody else who's trying to present data to you, explicitly define their statistic and their denominator, especially if there isn't a single agreed upon definition? Like death rate can be very amorphous and different people can use it to mean totally different things. Is the analyst, which again might be you, using relative rather than absolute measures to make tiny differences look big, or vice versa? Make sure you've really thought critically about what the better one to use in your particular case would be. And then whenever you're presented with a visualization, there's a whole bunch of things you need to consider. But if you can focus on just one thing, look at the axes and see if they are misleading. There is so much bullshit in the world from misunderstood or misused denominators. So I hope this lecture will be useful for you for your lives moving forward. Thank you very much for bearing with me. I will see y'all in class. Bye-bye.